Japanese standard, and US Army standards. Okay? So this is our Canadian standard, and the objective is the same as any other standard. It's to protect people, the content, reduce damage to building occupants and human casualties, and reduce damage to building, and then also facilitate emergency access to the building. So these are the objectives of the standard. First step is to again go outside of our typical expertise and define threat. So in earthquake engineering, what do? We go to seismologists and they give us ground motions, right? As structural engineers or civil engineers, we don't know how to get ground motions. They develop them, they give them as tools. Building codes specify spectral accelerations. And those spectral accelerations were developed by seismologists. And then we take maximum spectral acceleration, design our building. And here, similarly, we need security professionals who define threat. So what's the threat? It's a lot of filling forms, and I personally don't like it, but I have to work with them because it involves filling a lot of forms. What's the probability of somebody attacking this building, right? It's a very difficult question to answer. And they look at probabilistic approaches, past experience, and they monitor security if there's a threat to these types of buildings, and they eventually come up with threat, okay? And threat is specified as charge weight and standoff distance. In Canada, Royal Military Police, RCMP, as security professionals do that. In the US, FBI does that. And they usually don't tell structural engineers why, right? Now I'm working to mitigate blast risk for a Canadian embassy in Northern Africa, and they want me to do the analysis, but they did not specify the threat level. They said, well, we have to come and give you verbally, nothing has to be in writing. What if somebody gets hold of it? That's how seriously they take it, right? So I have to have professional security clearance to work for government jobs, and just like now, I didn't tell you which country where the embassy is. You have to keep secret. So this is secret, but they eventually give you that we think that this embassy is likely to be attacked by a truck or a car, and the road, the closest road is about 15 meters away. So these are the parameters you have to use. So given that, they gave me the charge weight and standoff distance, I immediately convert those to pressures and durations, okay? So the next challenge is a professional engineer, structural engineering challenge, and that is deciding on performance requirements. Now we are using performance-based design. Building owner, in that case, Global Affairs Canada, has to decide how important that building is. How much do they want to protect us, right? After all, it's an embassy, it's important, but it's not very, very important. So they may choose high level of protection, they may choose medium level of protection, they may choose low level of protection. Once they give that to you, as a structural engineer, you can decide for them. The building owner has to tell you level of protection, security professionals will give you a threat. With that two data, then you go and start crunching numbers, okay? So, performance objectives, having that piece of information, you have to limit, you have to control a number of things. First of all, you have to limit progressive collapse, and I'll talk about that at the end. And I already defined what progressive collapse is. You have to minimize damage to structural elements, and you have to mitigate damage to building envelope. Although some structural elements have collapsed in the past, as in the case of Oklahoma City bombing, as in the case of World Trade Center New York parking garage bombing, but most of the time, threats are to non-structural elements, building envelope, because masonry walls